Hello students, welcome to Interconnecting Physics. Today in this video I will explain you how to solve complex numerical problems related to combination of resistors. And in this video especially we will do Wheatstone bridge type problems and infinite network of resistors. So without wasting time, let's get started. For regular updates you can follow me on given links. So find the equivalent resistance between A and B. You see here, this is Wheatstone bridge. And to solve such type of network, we should follow the principle of Wheatstone bridge. That is, if R1 divided by R2 is equal to R3 divided by R4. This is R1, this is R2, R3 and R4. If R1 divided by R2 is equal to R3 divided by R4, then we will say this is balanced Wheatstone bridge. Balanced Wheatstone bridge. And in that case, the potential at point C is equal to potential at point D. That means no current will be flowing from the resistor R5 and we can remove this R5 resistor. So equivalent diagram will be like this is A, C, B and D. So it will be like this. This is R1, R2, R3 and R4. We can remove this CB resistors if only if R1 over R2 equal to R3 over R4. So let us understand this with taking some example. So find the equivalent resistance between A and B. This is the Wheatstone bridge and you see here R1 divided by R2. If this is R1, this is R2, this is R3, R4 and this is R5. Then R1 over R2 means 5 ohm divided by 10 ohm. The answer is 1 by 2. And what is R3 over R4? It is 4 ohm divided by 8 ohm and answer is again 1 by 2. So that means R1 over R2 is equal to R3 over R4. That means this Wheatstone bridge is balanced Wheatstone bridge and the potential at C is equal to potential at D. That means no current will be flowing from this 9 ohm resistor and we can remove this 9 ohm resistor from this diagram. So equivalent diagram will be this is B, this is A, so this is C and this is D. So that is 5 ohm, 4 ohm, 10 ohm and 8 ohm. Now you see here this 5 ohm and 4 ohm are in series and this 10 ohm and 8 ohm are in series. Why? Because let us say this point A is connected to some positive terminal of the battery and point B is connected to some negative terminal of the battery. Okay. Then point A is at positive potential and point B is at negative potential. That means if current I starts flowing through the positive terminal of the battery, then here it will get divided into two parts. Let us say I1 is going to AC resistor and I2 is going to AD resistor. Now at this point, there is no division, it is chain AC and CB. Okay, that is they are in series, so no current will be divided. This I1 current will go to CB and this I2 current will go to DB. And this combination I1 plus I2 will become I and same current will go to the negative terminal of the battery. So that means 5 ohm and 4 ohm are in series and 10 ohm and 8 ohm are also in series. So equivalent diagram will be 5 ohm, 4 ohm and 10 ohm and 8 ohm. This is point A and this is point B. Now, what will be the result of these two resistors? 5 plus 4 because they are in series and series the answer is R1 plus R2. So 5 plus 4 is 9 ohm. So equivalent diagram again. This 9 ohm and this is 18 ohm. This is point A and B. Now these two are in parallel and answer is R equivalent equal to 9 into 18 divided by 9 plus 18 which is equal to 162 divided by 27 and answer is 6 ohm. Okay, so in this way you can calculate the equivalent resistance between point A and B. Now next problem, find the equivalent resistance between point P and Q. This is also Wheatstone bridge type problem. Okay, so let us understand this. This is point P, this is point Q. Let us say this is point X and this is point Y. So let us draw X and Y. So this is 2 ohm, again P and Y. This is 4 ohm, again this is 3 ohm, X and Q 3 ohm, and Y and Q is 6 ohm, and from X to Y this is 8 ohm. Now you see R1 divided by R2, that is 2 divided by 4, answer is 1 by 2. Now R3 divided by R4, this is R3, this is R4, then R3 divided by R4 is 3 by 6, which is 1 by 2. So that means R1 divided by R2 is equal to R3 divided by R4. That means this is balanced Wheatstone bridge, and potential at point X is equal to potential at point Y. So we can remove this resistor 8 ohm because this is false connection. Okay. If this is balanced Wheatstone bridge, then we can say this is the false connection and no current will be flowing through the 8 ohm. So we can remove this 8 ohm resistor from here, and the equivalent diagram will be like X, Y, P and Q. So diagram will be like, if this is 2 ohm, this is 3 ohm, this is 6 ohm and this is 4 ohm, then these two are in series. So answer is 5 ohm. Again, these two are in series. Answer is 6 plus 4 is 10 ohm. This is point A, this is point B. Okay. Now 5 ohm and 10 ohm are parallel. So answer will be R equivalent equal to 5 into 10 divided by 5 plus 10. Next, find the equivalent resistance between point P and Q. Now again it is Wheatstone bridge. If you are given with 5 to 6 resistors, then always be sure this is the Wheatstone bridge type problem. Now point P, point Q, let us say this is point X, this is point Y. Okay, X and Y. So P to X, this is R. This is R. X to Q, R. X to Q, R. P to Y, this R, this R. Y to Q, this R. And X to Y, this R. So you see here, this is also Wheatstone type bridge. Now, since it is clear that R over R equal to R over R, so this is balanced Wheatstone bridge. So equivalent diagram will be like R, R, R and R. This is point Q, this is point P, because this is balanced Wheatstone bridge. So potential at X equal to potential at Y. So no current will be flowing through the resistor R, and this resistor can be removed from the diagram. Now these two are in series, these two are in series. So answer will be this 2R and this 2R. 2R and 2R parallel. So R equivalent is equal to R divided by N. What is R here? 2R. What is N? Number of resistors. We have 2 resistors. So answer is R. Okay. Now next problem. This seems to be very complicated problem, but this is very easy and simple. Now we start from upper portion of the diagram. Okay. Let us understand this. Now from here you see 2R divided by 2R. 2R divided by 2R, and here 2R divided by 2R. Both are equal. Okay. So that means if this is point X, this is point Y. Then we can say that potential at X equal to potential at Y. So no current will be flowing through this resistor, and this resistor can be removed from the circuit. Then equivalent diagram will be like 2R, 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 2R 2R. Okay, this is point A and this is point B. Now let us start from the lower portion of the diagram. Okay, you see from this diagram 2R divided by 2R means this divided by this, which is equal to this divided by this, 2R divided by 2R. That means this is also balanced Wheatstone bridge, and if this is point Z, then potential at Y is equal to potential at Z. So no current will be flowing through this resistor, and this resistor can also be removed from the circuit, and the diagram will be like this is 2R, this is 2R. Okay, so now these two are in series, these two are in series, these two are in series. So equivalent diagram will be like 4R 4R and 4R. Okay, so these three resistors are in parallel. Now result will be, let us calculate these two. The answer of these two will be 4R divided by 2, and answer is 2R. Okay, so diagram will be like 2R, because answer of 4R and 4R is 2R, and we are left with 2R and 2 small r. Now R equivalent equal to 2R into 2R divided by 2R plus 2R. So 4R divided by 2R plus R. So this is the equivalent resistance between point A and B, and in this way you can calculate the resistance. Now next problem. This is also Wheatstone bridge type problem. Let us understand RAD divided by RDC is equal to 15 ohm divided by 15 ohm. Answer is 1. Okay. Now RAO divided by ROC, which is equal to 15 ohm divided by 15 ohm, and answer is 1. So that means this divided by this and this divided by this equal. So this follows the balanced Wheatstone bridge, and potential at D and potential at O is same. So that means this 15 ohm resistor can be removed because no current is flowing through this resistor, and this is a false connection. Okay. Now let us understand this. RAB divided by RBC, which is 15 ohm divided by 15 ohm. Answer is 1. Now RAO divided by ROC. RAO divided by ROC, which is also 15 ohm divided by 15 ohm, and answer is 1. That means potential at O is equal to potential at B. So no current will be flowing through this resistor, and this resistor can also be removed. This can be removed, this can be removed, and equivalent diagram will be like this. This is A, B, C, D, O and C. Okay, these two are removed. Okay, now let us calculate this. We have to calculate the equivalent resistance between A and B. So let us draw the equivalent diagram. Earlier the diagram was this. Now let us understand this by drawing equivalent diagram. Now we have to calculate equivalent resistance between A and B. So A and C. So between A and C, these two are in series. This 15 ohm and this 15 ohm are in series. So let us draw 15 ohm 1. This is 15 ohm. 15 ohm. This is point D, and this is 15 ohm. Now A, O and OC are also in series. This is point O, and these are in series. 15 ohm and 15 ohm. Now point B. From C to B, 15 ohm. 15 ohm. Now from A to B, again 15 ohm. This 15 ohm. Okay. Now let us calculate the resistance. These two are in series, these two are in series. So answer will be 30 ohm, 30 ohm. So equivalent diagram will be like 30 ohm, 30 ohm, 15 ohm, and this 15 ohm. This is point B. Now these two are parallel, so answer will be 30 divided by 2, that is 15 ohm. So 15 ohm, equivalent diagram, 15 ohm, this is 15 ohm, okay, this is point A, this is 15 ohm, and this is point B, okay. Again I repeat, these two are in series, so 15 plus 15 is 30. These two are in series, again answer is 30, and this is point C, this is point C. Now these two are in parallel, so equivalent resistance in parallel is R divided by N. R is 30, number of resistor 2, so answer is 15 ohm. Now 15 ohm and this 15 ohm are in series, and this is point C, okay, and this 15 ohm from A to B. Now these 15 ohm and 15 ohm are in series, so diagram will be like 30 ohm, this is 15 ohm, this is point B, this is point A. Now these two are parallel, so answer is R equivalent is equal to 30 into 15 divided by 30 plus 15. Answer is 450 divided by 45, and answer is 10 ohm. So okay, so it is equivalent resistance between A and B is 10 ohm. Now next problem, again Wheatstone bridge type problem. Okay, now A, B, C and D. From A to C it is 2 ohm. From A to D it is 10 ohm. From C to B it is 4 ohm. From D to B it is 20 ohm. And from A to B it is 2 ohm. Okay, A to B. It is 2 ohm. Now from C to D it is 5 ohm. Now R1, if this is R1, this is R2, this is R3. R1 divided by R2, that is 2 by 10 is 1 by 5. And R3 divided by R4, 4 by 20 is 1 by 5. So that means 1 by 5 is equal to 1 by 5. This is balanced Wheatstone bridge. So potential at C is equal to potential at D. So we can remove this 5 ohm resistor because this is false connection and no current is flowing through 5 ohm. So we can remove this. Let us remove this. Okay. So we have removed. Now these two are in series. These two are in series. So let us draw the equivalent diagram. 2 plus 4 is 6 ohm. 10 plus 20, 30 ohm. This is point A, this is point B, and from A to B, 2 ohm. This 2 ohm here. Now these three are parallel, so R equivalent equal to 1 by 6 plus 1 by 30 plus 1 by 2, and LCM is 30. If this is 30, 5 plus 1 plus 15. So answer is 21 divided by 30, and R equivalent equal to 30 divided by 21. Okay. Now let us start with next problem, that is infinite network. We have done with Wheatstone bridge type problems. Now we are going to start the infinite network. It is also called as infinite ladder of resistors or infinite network of resistors or infinite grid of resistors. So here we have to calculate equivalent resistance between point A and B. You see here R, 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 R up to so on infinity. That means R unit. This R unit is repeating again and again. So what we have to do here, let equivalent resistance between A and B is X. We have to assume that is equivalent resistance between A and B is X. Now remove first unit from the infinite network. Remove first unit. Okay. Now what is the equivalent resistance of this infinite network? This is also X. Why? Because let us understand this by taking example of sea. Suppose you are taking a bucket of water from the sea. Okay. So is there any effect on the water of sea if you are removing one bucket of water from the sea? No, there will be no effect. Okay. And if you are adding this water into the sea, if you are adding, here you are subtracting. Okay. When you are subtracting one bucket of water from the sea, there will be no effect in the water of sea. And if you are adding one bucket of water into the sea, then there will also be no effect in the water of the sea. So same is happening with the resistor network. This resistor network is so large that if you remove one unit from this infinite network or you add one unit into the infinite network, then equivalent resistance will be same as that of equivalent resistance between A and B. Okay. So diagram will be like A. This is R. This is R. And this is X. We have assumed equivalent resistance of this network is X. Okay. And the equivalent resistance between A and B is equal to X. Okay. So now these two are in parallel. So answer will be, so equivalent diagram will be, this is R. These two are parallel. So answer will be Rx divided by R plus X. And this is point B. Okay, this is point A. Now these two are in series. So equivalent resistance between A and B, it is X, which is equal to R plus Rx divided by R plus X. So when we take LCM, so answer will be R plus X into X equal to R into R plus X plus Rx, which is Rx plus X square, which is equal to R square plus Rx plus Rx. One Rx cancels out with another Rx. The answer will be X square minus Rx minus R square is equal to 0, which is quadratic equation. And we know how to calculate roots of quadratic equation by using the formula x equal to minus b plus minus b square minus 4ac divided by 2a. Okay. So let us calculate x equal to minus b. Minus minus plus. So plus r plus. We take only positive root of this quadratic equation because resistance can never be negative. So plus b square, that is r square minus 4, a is 1, c is minus r square divided by 2a. So answer is, here we are calculating x equal to r plus r square plus 4r square divided by 2. So r plus 5r square divided by 2, this is x. Again r plus r under root 5. If we calculate the square root of r square, that will be r. So answer is this. If we take common r, 1 plus under root 5 divided by 2. So x equal to r by 2 into 1 plus under root 5. So this is the equivalent resistance between point A and B. Again I repeat, how we calculate? We assume the equivalent resistance between point A and B is equal to X. Okay, this is the first step. Second step, remove first unit. Remove first unit and assume the resistance of the network. Resistance of this network is again X. Why X? Let us say you are going to buy 1 lakh of resistors. Okay, and you are paying 2000 rupees. Now, if you ask shopkeeper to add 2 more resistors, only 2 resistors, then will he ask for money? No, because 2 resistors in 1 lakh resistors doesn't make any effect. And if you are giving 2 resistors back to shopkeeper, then will he going to deduct some money? No, because it will make no sense. Because 2 resistors in 1 lakh resistors don't make any effect. Okay. So this ladder is like this. If you remove 1 unit from this ladder or you add 1 unit to this ladder, this doesn't make any effect to the infinite network of the resistors. So equivalent diagram will be like A, B, this is R, this is R, and we assume the rest of the network has equivalent resistance X. Okay. Now let us calculate these two are in parallel. So RP parallel. So Rx divided by R plus X. Now these two are in series. So equivalent diagram will be A, B. This is R. This becomes Rx divided by R plus X, and this is point B. So these two are in series. So answer is equivalent resistor in series will be R plus Rx divided by R plus X, and we have already assumed the resistance between A and B is X. So that means X equal to R plus Rx divided by R plus X. Now solve this equation for X. This will become a quadratic equation, and you have to solve the roots of that quadratic equation, and we will take only positive root of the quadratic equation because resistance can never be negative. Let us understand this by taking some examples. Suppose this is the infinite ladder, okay, and we have to calculate equivalent resistance between point A and B. So first step is let RA be equal to X. Now remove first unit, and rest of the unit has equivalent resistance again X. So equivalent diagram will be 1 ohm, this is 2 ohm, point A, point B, and this is X. Okay. Now these two are parallel. So answer will be 1 ohm 2x divided by 2 plus x. This is point A, this is point B. Now these two are in series. So answer will be X. Why X? Because we have assumed resistance between A and B is X, which is equal to 1 plus 2x divided by 2 plus x. If we take LCM, answer will be 2 plus x into x equal to 1, 2 plus x plus 2x, and this is 2x plus x square, which is 2 plus x plus 2x. 2x cancels out with 2x, so answer is x squared minus x minus 2 equal to 0. So this is quadratic equation. Let us solve this for x. We take only positive root, okay, minus b, minus minus plus, so plus 1 plus b square 1 minus 4ac, c is minus 2, and divided by 2a, okay. So 1 plus 8 divided by 2, which is 1 plus under root 9 divided by 2. What is the square root of 9? It is 3. So 4 divided by 2, and answer is 2 ohm. So equivalent resistance between point A and B is 2 ohm. Okay. This circuit can be like this: 1 ohm, 2 ohm, 2 ohm. This is point A, this is point B. And repeating unit: 1 ohm, 2 ohm, 2 ohm. This is up to infinity. So we remove first unit, this, that is 1 ohm, 2 ohm and 2 ohm. And rest of the unit will have equivalent resistance X. Okay. So in this way you can solve infinite network type problems and also Wheatstone bridge type problems. So this is all about today's video. Thank you very much. Don't forget to like, share and subscribe. Stay happy, stay healthy.